Okay, so let's go ahead, right? Okay, so hello everybody. Welcome to the fourth AppEEL webinar series. This webinar is organized together with the Cosmic Lab that is co-headed by Francesco Ferretti, who will be my co-host here today. Francisco, hello. And so we have hello. And so we have three speakers today. We have Ian Tattersall, and then we have three speakers more, Francesco Ferretti, Ines Adornetti, and Alessandra Chiera from the University of Roma Tre. And then our third speaker today is Rob DeSalle. And Francesco will be introducing our first speaker today, who is Ian Tattersall. So Francisco, please go ahead.
Thank you, Natalie. Thank you for the organization and for the kind invitation. Okay, my job is as a presenter is very simple today because Ian Tattersall is well known everywhere in the world. So I just prepared a brief schema to present him, and he's a leading scientist in the field of human evolution, with several scientific publications, is a great interpreter for primatology and human paleontology, with wonderful books on the topic, a number of major exhibits in American Museum of Natural History. So we have the honor to welcome Ian Tattersall, who will talk about the emergence of modern human consciousness. Maybe 20 minutes, 25 minutes, right, Natalie? For any talk?
Yeah, so it's like 20, 25 minutes, yes.
Okay. So yeah, you can start.
All right. I'm unmuted. Can you all hear me?
Yeah.
Okay, great. So as I was saying before I was muted, it's amazing to me to be able to speak to so many different people in so many different places at the same time and at so many different times of day. And so today I don't want to take up too much of your time, but I want, in a really quite breathtakingly superficial way, to address the issue of how we human beings came to be the rather extraordinary and quite frankly, highly improbable intellectual entities that we are. And now that's going to involve, and I'm going to need my glasses for this. It's going to involve sharing my screen and going to my PowerPoint and playing it from the start. And there we go. All right. So my first point is that while there can be no rational doubt at all that we living Homo sapiens are fully integrated into this great tree of life that we see here and that I stole from Rob DeSalle, this tree unites all living organisms on the planet, and we're definitely and unquestionably embedded deep within this nested tree. But there is nonetheless something that is qualitatively unique about us, and particularly about the way in which we process information in our minds. And the key to this difference seems to be that we human beings think symbolically, unlike even our closest primate relatives. And to say that we think symbolically is basically a way of saying that we mentally dissect our exterior and interior worlds into a vocabulary of discrete symbols, discrete mental symbols, and then we can rearrange those symbols according to rules to imagine alternate versions of those worlds and to envision new possibilities about them. It is the foundation of our creativity and the possibility of creative, generative thought. Now, of course, our close relatives, the apes, can readily recognize and respond to symbols. And they can even use them additively to make and to understand simple statements like take red ball outside, as these bonobos appear to have done in this picture here. But what apes evidently do not do is to engender multiple alternatives by rearranging those symbols in the human fashion, leaving a huge cognitive gulf between them and us. So we have to ask ourselves, how did we human beings acquire their cognitive uniqueness in some time in the last 10 million years or so that separated us, our ancestor, from theirs? Was this acquisition a process of slow and directional modification under natural selection, as many believe it was? Or was this acquisition through a process of a rapid shift that may have contained a more random element to it? Well, there's been a lot of speculation about this. And one putative indicator of the nature of the process that produced us is the shape of the human family tree itself. And here's one version of that tree. And as you can see from its very vigorously branching form, it doesn't suggest in the least that the lineage leading to Homo sapiens was modified slowly and steadily in our direction. Instead, what this figure here suggests to me, what this tree suggests, is an ongoing process of wild experimentation with the hominid potential, with numerous species being spun off and tossed out into the ecological arena to survive or to perish. But while a diagram like this gives us some idea of process, it really tells us nothing about the history of human behaviors. Although brains, as you can sort of see from this figure, brains became pretty consistently larger over the past couple of million years or so. And hominin behaviors obviously also became more complex at the same time. But unfortunately, that's a story we don't have time for here in 20 minutes. But the bottom line of all of this is that clear evidence for the symbolic behaviors that distinguish modern humans does not appear until very late in time. For example, the fairly large-brained Homo heidelbergensis, which appeared around 600,000 years ago, was undoubtedly extremely smart and resourceful and behaviorally flexible and inventive. And in its tenure, things like the pointed throwing spear, death at a distance, was invented. Deliberately constructed shelters were invented, and the hafting of simple stone tools into handles was invented too. These were all major technological innovations. But I think that what this remarkably inventive hominid does above everything else is it's possible to be smart and resourceful and behaviorally flexible and inventive and all those things in the absence of any evidence for symbolic reasoning. They left us nothing that suggests that they were symbolic. They were highly technological, they were highly intuitive, but they weren't symbolic. And what is more, we can say exactly the same thing for, oh my gosh, here I have some examples of what Homo heidelbergensis did. It's a Homo heidelbergensis hut. And we can say the very same thing for the slightly later Homo neanderthalensis, which is a European hominid that evolved from indigenous predecessors at around 200,000 years ago, with a long lineage in Europe going back way before that. Now, the Neanderthals, as you can just see from this reconstructed skeleton here, had brains that were as large as ours, although they were housed in a skull of a very different shape, as you can see. And the Neanderthals were wonderful craftsmen in stone, as you can see here from a couple of their so-called Mousterian stone tools. And they left us an incomparable record of very complex lives. They flourished in an age of very difficult climates. They hunted some really fearsomely large animals like these woolly mammoths. and at least occasionally they buried their dead. But despite this odd straw in the wind, the Neanderthals actually bequeathed us very little convincing evidence that they had possessed any consistent tradition of symbolic activity. And in a record that was as geographically and as temporally and as materially expansive as a Neanderthals record was, if these hominids had been symbolic thinkers like us, they would surely have left us more convincing indications of this fact. And even more amazingly, the same identical thing can also be said of the earliest fossil representatives of our own very anatomically distinctive species, Homo sapiens. Now, Homo sapiens initially clearly evolved in Africa because the earliest fossils to show substantially modern morphologies, like the one we see on the screen here, have been found at Ethiopian sites that date to between 200 and 160,000 years ago. But significantly, these early anatomically modern humans are associated with some notably archaic toolkits, including this very late hand axe, which was picked up not far from where the skull we just saw was found. Now, obviously, members of our species eventually began to reason symbolically, or we wouldn't even be here discussing the subject today, let alone across the continents. But it's not until around 100,000 years ago or so that we start finding any substantial indication that humans were behaving in the symbolic way that we're familiar with today. At around that time, 100,000 years ago, pierced marine shell beads like these and ochre deposits, ground ochre deposits, start to show up at sites around the Mediterranean basin and in South Africa. And they're putative evidence of bodily decoration, which among modern humans at least is almost always symbolic in some way or another. And soon thereafter, soon after this 100,000 year point, the first explicitly symbolic objects begin to show up at Blombos Cave, the site that we see here near the southern tip of Africa. And at Blombos, levels dated to almost 80,000 years ago have yielded smooth ochre plaques like this one that bear an engraved geometric motif that appears to have retained meaning. It has held meaning and retained it over time. And this is the most convincing evidence we have for early symbolic activity around 80,000 years ago. And it's now been joined by the world's first known drawing, also from Blombos Cave. And this, if you can see it, is an abstract design that was drawn 73,000 years ago on a piece of silkcrete, a piece of local rock, using an ochre crayon. At about the same time, technology was also roaring ahead, as attested to by such complex activities as the fire hardening of the silkcrete flakes from one of the caves at Pinnacle Point, also near Mossel Bay. It's not very far away from Blombos at all. And this is really a complex multi-stage technology that required a great deal of planning. Now, significantly, all these things we've been seeing here from Blombos, from Pinnacle Point, are the work of anatomically modern humans, which suggests, to me at least, a very specific scenario of modern origins. All of these expressions of complex reasoning, if you will, are the work of Homo sapiens. And it suggests that clearly recognizable Homo sapiens, like the one that we see here, appeared as an anatomical entity, a distinctive anatomical entity in Africa at about 200,000 years ago. Now, at first, members of the new species behaved in pretty much the same way as their predecessors and their hominid contemporaries had done and were doing. But by around 100,000 years ago or so, or soon thereafter, they were beginning to show a new and unprecedented behavioral tendency that included the production of symbolic objects. And very soon after, as this map shows, populations descended from those first symbolic humans, exited Africa, and very rapidly took over the world. From Homo erectus in the Far East to Homo neanderthalensis in the far west of Eurasia, all hominid competitors promptly disappeared once Homo sapiens had emerged from Africa. And in the best documented case of early behaviorally modern penetration of remote European regions, the dazzling tradition of European cave decoration was already underway by around 40,000 years ago. And it was accompanied by an incredible record of musical instruments and notations, and record keeping, and portable art. Nothing more exquisite than this horse in mammoth ivory has really ever been produced, in my opinion. And so there's a huge inflection that we are seeing in human behavior at around this time. And once more, this isn't just reflected in Europe. This rock image of a native pig from Sulawesi in Indonesia was recently dated even earlier than the earliest European art, to over 43,000 years ago. And that suggests to me that the tradition of representational art that we now see both in Europe and in Asia had originated earlier yet from a common source. And that source, of course, was most plausibly in Africa, and it must have been very soon after the emergence of a symbolic cognition in that continent. So in the short period between about 150,000 years ago, a fundamental behavioral transformation within the species Homo sapiens had sparked a revolution in the way in which humans did business in the world. And clearly, we cannot implicate natural selection in this virtually instantaneous behavioral transformation. And of course, we also have to bear in mind that that transformation must necessarily have been permitted by neural structures that were already in place. You can't have a new behavior without already having the structure that permits it. And there was only one obvious biological event in which those structures could have been acquired, and namely the radical developmental reorganization that resulted some 200,000 years ago in the highly derived skeletal anatomy of the new species Homo sapiens. You can see quite how distinctive we are anatomically by comparing the human skeleton on the right here with that of the Neanderthal on the left, which is in most bodily features a pretty representative Middle Pleistocene hominid. The differences are enormous, and they go from head to foot. So clearly, the genetic alteration that was involved in the speciation of Homo sapiens had cascading developmental consequences throughout the body, and almost certainly including in the brain as well as in the hard tissues, which is the only thing that we have left to look at. But the lag that we see in the archaeological record nonetheless suggests that the new cognitive potential that was born in this event lay unused for a short but significant length of time. And during this time, anatomical Homo sapiens continued to behave in the old manner, producing a pretty unremarkable archaeological record. But then something that was necessarily behavioral, of course, happened to stimulate the recruitment of the new behavioral potential. And by far the most plausible candidate for the stimulus, here's the brain, there we go, the most plausible candidate for the stimulus that was concerned in this event is the spontaneous invention of language, because language is the ultimate symbolic activity. And indeed, from our modern perspective, language is virtually impossible to imagine in isolation from thought. and vice versa. And my colleague, the linguist Wolfram Hintzen, has, for example, a few years ago recalled the very close connection between grammar and thought. And he's even suggested that thought itself is inherently grammatical. So in other words, language and modern thought are so closely intertwined that they appear to be functionally, if not conceptually, inseparable. And what's more, the invention of language by a biologically predisposed hominid could easily have been more or less instantaneous. On a theoretical level, for example, Noam Chomsky and his buddies have recently argued that the algorithmic basis for language is extremely simple. And field linguists have observed structured sign languages emerging virtually instantaneously among communities of deaf children who are housed together for the first time. And those languages then very rapidly evolved in structure and sophistication. And this property of suddenness, the ability to be suddenly acquired, not only makes language a particularly credible driver of the abrupt emergence of symbolic reasoning, but it also distinguishes it from all other rival stimuli for symbolic thought. And of course, in addition to its internal importance in organizing thought, language is an externalized attribute that would have been poised to spread rapidly within any population, within any species that was already biologically enabled for it. So in the scenario I'm proposing, language and symbolic thought were inextricably intertwined in human history. And the two of them were simultaneously acquired by Homo sapiens in a single short-term feedback event, an event that was both recent and emergent. And it was an exaptive event rather than an adaptive one. Now, this notion that the human brain underwent a recent and sudden algorithmic shift, a radical change in the way in which it worked, is supported by the rather counterintuitive fact that after 2 million years of steady expansion, our human brains have apparently shrunk significantly since the end of the last ice age. Both the Neanderthals and the early modern Europeans who replaced them at around 40,000 years ago seem to have had brains of approximately equal volume, making both some 13% bigger than the brains of the average person today. And especially because brain is metabolically a very costly tissue, this suggests very strongly to me anyway, that the ancestral intuitive hominid brain operated on a brute force algorithm in which intelligence, however you might want to define it, intelligence scaled more or less directly with brain volume. But the new symbolic algorithm, in contrast, turned out to be a much more metabolically frugal one, demanding less energy input to produce a very cognitively distinct product. And as accidental as it might have been, the resultant cognitive style made its possessors significantly more effective in the competition for ecological space than any other hominid that had previously existed. In fact, so effective indeed was it that the early symbolic humans rapidly cleared out the competition and bequeathed us our unprecedented status as the world's only hominid. Now, the unique mode of locomotion the unique mode of information processing that permitted this was evidently acquired amazingly recently and in an abrupt event that was entirely random with respect to adaptation. And that makes it clear in turn that we human beings have not been programmed by eons of evolution to behave in the specific ways that the evolutionary psychologists like to suggest. Instead, the entirely adventitious adoption of symbolic thought abruptly changed all the cognitive rules and put us into a completely unknown and unprecedented arena. And knowing this fundamental fact is incredibly important, I think, because it helps us to understand why, after so many millions of years of evolution, we are still such patently unperfected creatures. It also helps us to explain why our decision-making processes are typically so messy. Who knows what's going on in this guy's mind? And in addition, it also makes it easier to understand why, for all of our amazing rational powers, our behaviors are so frequently irrational and self-destructive. And finally, it helps us to comprehend that these imperfections, these cognitive imperfections, are the price that we pay for our precious ability to make choices. Thank you all for listening, and I hope that was 20 minutes. And now I stop sharing.
Okay.
And we can go back to real life.
Thank you very much, Ian. We have, I think, 10 minutes for a discussion, probably at the end of the 3 talks for a general discussion. We can have more time. Do you have a question?
This usually annoys the hell out of most people, so you know, if you have any issue to take with it, well, I wouldn't be surprised at all. The problem is that this is, you need, I mean, this is a lot to get into 20 minutes, and I would like to be able to set the background a little bit more comprehensively, but I hope it made sense.
It makes sense. I have a question, because these days a lot of people are saying that Neanderthals had language and that they had symbolic reasoning. Yep. And some people even think that they might have made some of the artwork that you find in the Spanish caves. And you are one of the scholars that says no, they are not. Mm-hmm. And why? Why? Like, for example, when you show that nest of Homo heidelbergensis, what is not symbolic about it?
What's not symbolic about Homo heidelbergensis is it didn't do anything symbolic. It did a lot of very practical things. Everything the Homo heidelbergensis did was supremely practical. And we have this real problem in comprehending that an organism can be really smart and not work exactly the same way that we do. We cannot really imagine what it is like to be extremely smart and sophisticated and able and not to think exactly the way that we do. We're not talking about a huge difference here, but we're talking about a very significant one. But it's not, it's evidently not a gigantic gulf to be crossed. But if you look at Homo heidelbergensis, they were pretty admirable, but they didn't produce anything that was in any way symbolic. The only thing that comes from Homo heidelbergensis times that is conceivably a symbolic object is the Berecat ram, so-called Venus, which is a rough piece of tooth that has been roughly in the shape of a female torso that may or may not have been modified to exaggerate that resemblance. Not everybody accepts it as having been modified intentionally, but it's one thing. And then, of course, when we move to the Neanderthals, yes, there are all kinds of manifestations, one here, one there, one somewhere else, scattered in time, scattered in space, of doing things like making necklaces out of eagle talons. You know, that at one time we thought only Homo sapiens did. But when you look at the totality of it, when you look at the totality of the record that the Neanderthals left, when you look at what their lifestyle might have been, it's clear that they had a different relationship to the world than we do, and than the Cro-Magnons did. So that we have a particular way of reconstructing the world in our minds that I don't think was a regular possession of Neanderthals. There was occasional smart Neanderthal that did something here and there, and that's not surprising. I mean, there's a huge variation in how smart members of a species can be. And with a big brain form like Neanderthals, I'm not surprised to see the occasional expression of something that we thought that only we were smart enough to do. But you look at the totality of that record, and the Neanderthal record is so unlike us. Indeed, I would argue that if the Neanderthals had manipulated information about the world in their minds the way that we do, they would have screwed up the world in the way that we have. And just the fact that they didn't do that suggests to me that there's a difference. So there's
a question. There's a question from Selene Arfini.
Yes, it may be a silly question actually, but just to be clear, when you use the term symbolic, you don't mean representational, right? Or because we have,
yeah.
When you use the word symbolic, yeah, it's equivalent for you as representational or not?
Representational of ideas, but not of objects, right? So a geometric engraving might well encode a concept, and in that way it would be symbolic, but it wouldn't represent whatever it was encoding. I think the great thing about Ice Age art is all the animals are very clearly symbolic of what they represent, and that connection is very easy to make. But there's a lot of geometrical engraving, non-geometrical engraving that is clearly symbolic in intent. And you see these symbolisms sometimes repeated from one side to the next to the next. So they had a consistent, they bore a consistent meaning, but we can't know what that meaning was, you know? So it's...
I see what you mean, but that's like, what I find difficult, sorry.
Yeah. Now, I want to say something else about symbolic too, because everybody has a different idea of what symbolic means. And frankly, my idea of symbolic is I'm using it as a shorthand for something I don't fully understand, right? I don't know what it is in the brain that what's going on that converts a bunch of electrochemical discharges into what I experience as my own consciousness and my own awareness of what's going on in the world. I'm talking, so in a way, we're talking, using this word symbolic as a shorthand for something that we don't fully understand. But I think we can see the difference. You know, it's just like the American Supreme Court and the judges and pornography. You know, they don't. They don't know how to define it, but they know it when they see it, you know, and in a sense, you know, in terms of inwardly looking at our own consciousness, we're at a similar stage of comprehension of what's going on inside ourselves. We know there's something different. You can look at a chimpanzee and say, and it's looking at you, and you know there's something going on in there. You know it. that's an intelligent animal and there is a certain amount of cogitation going on, we kind of have no idea what that is. And in fact, we only have a subjective awareness of our own mental processes. Really, we don't have a very good objective way of describing what's going on.
There's a final quick question of Amadeo Viana.
Hi.
Okay, thank you. I would like to know your opinion about this question. Do you think that the early post-brain growth, which accelerates during the last 100 mile year of years, or the early postnatal growth acceleration has a role to play with the development of particular symbolic thought in Homo sapiens? I mean, this is strict question, which is related to our last period of evolution, our last 100.
Yeah. No, I mean, that's a very good question. And, you know, intuitively, you would think that since we are the product of you know, 2 million years of steadily enlarging brains among the hominids, that this might have something to do with the way we think. And what really blows me away is that since we started to think symbolically and behave symbolically, our brains have gotten smaller.
Yeah, that's
just me that you've got this brute force algorithm that is driving hominid brain size earlier on.
All
the more brain you have, you know, brain is expensive. You know, you don't have it if you don't need it. You know, you're not getting a lot of benefit from it. It has to pay the rent, and so brain size was becoming bigger and bigger and bigger, and in multiple lineages, independently in multiple lineages of hominids. So what members of the genus Homo were doing across different species was obviously very important in driving the increase in brain size, and Homo sapiens was part of that. But then something happened in Homo sapiens that switches brain to a different algorithm. And that's the only reason I can see. You know, people have put forward all kinds of explanations for why brains have gotten smaller in the last, last 40,000, 20,000 years. Nobody really knows for sure. But for me, the notion of a more tissue frugal algorithm is not a bad explanation, and that goes along with the symbolism. So I would tie those two together. Yeah. Not that we couldn't, but we had to go through the brain expansion before we could contract it, as it were.
Yeah. Okay. Thank you.
Well, there you go. Thanks.
Thank you very much, Ian. Thank you very much for your talk. So now let's move on to the next speaker, which are three speakers associated with Francesco Ferretti. So Francesco Ferretti is a full professor of philosophy and cognitive science at the Roma Tre University, and there he is also the director of the Cosmic Lab, which is a lab with which we are co-organizing this webinar today. And two of his students, Alessandra Chiera and Ines Adornetti, are here with him, and they are going to talk about proto-language, because all of us are also associated with the Ways to Proto-Language Conference series, which is associated with Slavomir and Przemysław Sikwizinski, who are also here in the audience. So Alessandra, please go ahead.
Yes, thank you, Natalie. I'm going to share the screen. So can you see my screen?
Yes, we can.
Okay, so in this talk, we are going to speak about narrative pantomime, so a form of proto-language which we propose to be a stepping stone to for the emergence of the modern language. And this is the outline of our talk. So the main idea underlying this talk which we would like to suggest, is that communication, human communication, is a form of persuasion, and that human language evolved basically to change the other's beliefs and attitudes, so to make people act in a certain way. More specifically, we propose that humans created a specific way to persuade others through the development of a specific form of communication that is narrative persuasion. And our claim is that narrative persuasion is what distinguishes human language from animal communication, so from other forms of communication. Again, against this background, we suggest that the early stages of communication, so very long before the emergence of verbal language, in these early stages, archaic hominins used forms of pantomimic storytellings to persuade others. And in support of this view, we will try to suggest that our ancestors were endowed with cognitive systems to mentally represent reality in a narrative format, and that pantomime represented a powerful means of expression to convey narrative representations. So a first step to outline this proposal concerns the model of communication to refer to. And in this regard, there are two major models that have been proposed in the literature, the informative model and the manipulative model. According to the informative model, animal communications, so communications basically as the function to transmit information, so to the production and perception of signals. But we commit to a second perspective, so to the manipulative model of communication, which has been advanced basically by Dawkins and Krebs, and has been further developed by other scholars. So according to these models, animal communication is basically competitive and evolves to manipulate receivers rather than faithfully inform them. So the function of signals in this view is that the receiver has to respond in a certain way that provide advantages for the sender, but regardless of any benefit for the receiver. Which is the advantage of framing human communication in this kind of framework. Certainly is the idea that human communication can be seen in continuity with animal communication. However, we should recognize that the manipulative model has some difficulties when applied to human communication, in particularly the difficulty of explaining how to move from manipulation to persuasion, and of understanding how to deal with some criticisms that are important and that concern the passivity of the recipient. The criticism towards the idea that the recipient has a passive role concern basically 2 points. First point refers to evolutionary issues. So within the manipulative models, the adaptive benefit seems to be exclusively on the side of the actor, and so it remains unclear why the receiver should be selected to reply to the sender in a communicative context. As Seifert and colleagues have highlighted in this paper, an analysis that allows the signaler's behavior to evolve but does not permit any evolution in receiver's response does not make any sense. And a second criticism concerning the passive role of the recipient has to do with the nature of the human communication. A basic intuitions and yes, common sense contrast this view that the listener is a passive subject in communication. And these intuitions have been also confirmed by some empirical research. In this regard, it is important to stress that a critical feature of human communication is the listener's defense towards the persuasive intentions of the speaker. So when the listener recognizes the persuasive intentions of the speaker, she develops strategies to defend, and this have been termed epistemic vigilance by Sperber and colleagues. Sperber and colleagues claim that these strategies, which include defensive and monitoring mechanisms, make the listener to be constantly able to evaluate the truthness of what the speaker is saying and to take part in the conversational exchange in an active way. So the active role of the listener has important consequences, important implications on the speaker's persuasive strategies, because the speakers is constantly engaged in an effort to overcome epistemic vigilance to persuade the others. And this kind of strategy prompts the evolution of new persuasive strategies in humans. And according to Sperber, this and we refer to Sperber in this. We agree with him. Human communication is different from the manipulative model of human communication because of these strategies. But we frame these strategies in a different way than Sperber. So what Sperber and colleagues are claiming, they argue that speakers developed strategies that are based on reasoning and argumentation. So argumentation is the center of human communication in their opinion. So arguments are clearly a kind of inferences which are generally assumed to rely on the constituent structure of sentences. And since the structure presumes verbal languages, then argumentation is likely to represent a late product of the evolutionary process rather than a starting platform for language emergence. So this is our criticism towards the Sperber's and colleagues' idea. So in other words, although being extremely effective on a persuasive level, argumentation cannot be a good starting point for language origins. So following these preliminary considerations, our proposal here today in this talk is to suggest that in the early stages of language evolution, the enhancement of persuasive abilities led to narrative strategies that were persuasive on one side, but on the other side, they were not argumentative. So they were persuasive without being argumentative. Before exploring why narrative can be seen as a persuasive form of communication, just a brief definition of narrative, which is of course required. There is a wide debate within narratology and other fields about a good definition of a narrative, but there is a general definition which is suitable and which reaches I would say a large consent, and describes narrative as a primary resource for configuring events into more or less coherent scenarios involving the experience of persons. So we start from this very basic definition, which can be then more better articulated. So we should say that there are several reasons that make narrative an excellent means of persuasion. Here we will focus just on two mechanisms which can account for this power of narrative, and these are transportation and engagement. Why these two mechanisms? Because it has been shown that stories are effective means to inhibit the defensive strategies of the listener, since the narrative form has the power of this expression, flying under the radar. So stories allow to achieve the storyteller's persuasive aims, hiding this persuasive intent. So in this way, stories can bypass the natural defensive reaction of the audience. And this can be described as a non-argumentative way of achieving persuasion that relies on mechanism of transportation and engagement. And there is a model proposed by Green and Brock, the transportation imagery model, in which they propose that the reader loses access to some real-world facts in favor of accepting the narrative world that the author has created. So in this way, while the reader is immersed in the story, she may be less aware of the real-world facts, and this can undermine her ability to counter-argue, making her more willing to accept the story claims and thus more easily swayed, influenced. So since stories can have a persuasive power, and since in our hypothesis narrative precedes language, we now need to understand how our ancestors could narrate for persuasive aims before the advent of verbal language. And to address the issue, we refer to two main conditions which are related to a narrative proto-language. Structural conditions, which concerns the cognitive systems involved in storytelling, and materials conditions, which refer to the expressive system that was suitable for telling stories without language. So as for the first point, so the structural conditions, so we have emphasized the role of transportation and engagement in persuasion, and we should find some cognitive systems that must be capable of accounting for these two mechanisms. And in this regard, we can refer to two main cognitive systems, which are very relevant, those underlining spatial and temporal projection, and those underlining social simulation. Why are these systems so relevant? Because the systems of spatial and temporal projection seem to be crucial in transportation, because they allow the reader, the subject who is processing the story, to project from the current location into the narrative by means of a process which has been named scenario construction. And what this process allows is a construction of a mental model of the story, binding together multiple elements of the imaging scenes like those described in a story. And systems involved in social simulation, these are used to give meaning to the action of the characters. And in particular, they are critical to create forms of engagement with the story characters. How they can do this? Because they allow to the audience to enter into the life of the characters by simulating their thoughts, feelings, desires, and so on. And what it's relevant for our argument is that this kind of systems of the narrative brain have been shown to be not specific to language. So they are present to various degree in other non-human animals. Of course, this topic will deserve an in-depth discussion, but just for the purposes of this talk, we can say that there is some evidence showing that, for example, great apes can project into the past, into the future to a greater and or lesser extent. And similarly, there is evidence that many of the core components underlining social simulation are rooted in our primate past. So these findings are important because they open the way to the possibility that also our hominin ancestors could have this kind of systems for social cognition and spatial and temporal projections, and then these systems have been exploited for communicative purposes. So if the narrative brain is a precondition that was already present in our ancestors, a next step is understanding what kind of expressive system was better suited for telling persuasive stories in the absence of verbal language. And our claim in this regard is that pantomime, and more specifically a form of pantomimic storytelling, could represent the proto-language that, although not relying on argumentative persuasion, could allow our ancestors to convey specific forms of persuasive communication that were different from those of other animals, so that distinguished our kind of communication from that of other animals. To understand how pantomime can be this kind of tool, so a means of persuasive proto-narrative, we need a good definition of pantomime, clearly. And in this regard, we propose to combine two definitions that have been proposed independently by McNeil on the one side and by Dziewiczinski and colleagues on the other side. And these are definitions that, taken individual, have some limitations for our purposes. So McNeil proposed a definition which seems to perfectly fit with our hypothesis, since he makes an explicit reference to narrative. So he describes a narrative as a gesture or sequence of gestures conveying a narrative line with a story to tell produced without speech. So in his view, gestures can do this because they can pack meanings in a global way, so moving from the whole to parts. However, there is a problematic aspect in McNeil's proposal because this potential of pantomime does not fit with a pantomimic scenario of language evolution in his view. He claims that pantomime is an evolutionary dead end, nothing have to do with with language. Because in his opinion, language from the very beginning relies on an integrated system of gesture and speech, while pantomimic gesture is considered to be a silent gesture. And Dziewiczinski and colleagues have challenged this view, this point specifically, showing that pantomime is inherently multimodal, so involves different sensory channels from the beginning, and is polysemiotic, so can combine from its very beginning different semiotic modalities along the visual one. So, for example, the non-linguistic vocalization and depiction. So they provide a rich definition of pantomime, describing it as a nonverbal, mimetic and non-conventionalized polysemiotic communicative system, which holistically refers to events displaced from the here and now by means of coordinated movements of the whole body. And we find very convincing this idea that the emphasis that they put on the multimodal and polysemiotic character of pantomime, as well as its holistic nature. So with they describe this feature as the fact that there are no self-apparent onsets and terminations in the stream of movement. So these aspects are particularly relevant for our narrative conception of pantomimic communication. However, Dziewiczinski and colleagues do not explicitly refer to narrative in their definitions, which in our definition, in our perspective, is a defining trait of pantomime. So our proposal is to integrate these two definitions by keeping together the holistic, multimodal, and polysemiotic character of pantomime with the narrative plan. And in this way, we can raise the hypothesis, of course, it's just an hypothesis, that pantomimic communication represented a scaffolding for expressing narrative thoughts before the advent of verbal language. So the idea is that our ancestors could exploit pantomime to persuade others without using argumentation. So using a pre-argumentative form of communication, of persuasive communication. So just to sum up, we started from the idea that animal communication can be described as persuasive. And then we proposed that in archaic hominins, communication was persuasive as was narrative at a pre-argumentative level. Of course, we did not address the last issue because we dealt with proto-language, focusing on pre-argumentative forms of communicative persuasion. The next issue is to explain how to move from this forms to this, from proto-language to modern language. So how to move from forms of persuasive narration to persuasive argumentation. Because human communication is clearly persuasive as narrative and argumentative in character, but this can be a topic for a next talk, maybe, if you want. So thank you for your attention.
Thank you very much, Alessandra. Thank you very much. Let me go to a gallery view. Okay, thank you. Questions?
Could I say something?
Yes, yes, please. Please go ahead.
Yeah, are you guys familiar with the with Susan Schaefer's story of Ildefonso?
No.
Nope.
All right. Susan Schaefer was a sign language teacher who had a succession of students, and when this guy she calls Ildefonso came along, she realized there was something different about him, but she wasn't sure what it was until she realized that unlike all of our other deaf sign language students, this guy didn't even know that things had names. He had to learn, first of all, that things had names before they could even start the sign language. And in the end, he did, and it was a big emotional experience for him. And anyway, so he learned sign language, and it later turned out that he had associated with a group of similarly deaf people who hadn't got the idea that things had names. And they got together. And when they got together, they indulged in elaborate pantomime. That's what they did. That's what they did. The pantomime, they were acting out situations. And they were communicating, but it took a long time, to get the point across, like playing charades. But, it worked for them. And then Ildefonso learned that things had names, and he learned sign language, and he went back to see his friends, but he just got fed up. These were his friends, but he didn't have enough patience to deal with them because, he knew things had names and they didn't. And eventually he stopped associating with them. And now this is a extremely anecdotal account by not a scientist, by a sign language teacher. But I think it tells us an awful lot about how language may have been acquired and the kind of change that it made. And it fits in very nicely with what you guys are saying. So she wrote a book called A Man Without Language or something like that. It's a good read. It's not science, but it's a good read.
There are two questions from Paulo, but do you want to react first, Alessandra?
No, I just want to thank Professor
I
Tattersall.
could react, if possible.
Yes, Francesco, please go
Yes,
ahead.
because it's right that there is an important relationship between name, I think, and but at the level of perception, it's impossible to see just an object. Anyway, I see an object, I see a scenario, and the scenario is a way to organize a narrative experience of the perception. So we can say that really, any way we can see an object, we can see a story of the object. But for example, the fact that in seeing an object, I project myself in the future, imagining the use of this object, or in the past, for example. That means that the perception of, even the perception of a simple object is because of our narrative brain, is the perception of a narrative, of a story. So the fact that we can associate a name with a thing is not incompatible with the idea that stories precedes the name.
Not at all. I think you're quite right, and I think that fits in very well, you know, with what Susan Schaefer observed. I mean, your scenario here, I think, is a beautiful fit with something she observed in the real world, and I think that's really cool.
I see that Anton Sukoverkov here has put in the chat that it is a man without words.
A man without words.
Man without words. Thank you, Anton. Alessandra, did you also want to reply?
No. I was thinking that what Francesco was saying is in line with Professor Tattersall thought, I think, but he can reply. Yeah.
I have a question.
Yes, but wait, Amade, please, because there are two other questions already from Paulo Abrantes and Presmislav. So Paulo, please go ahead.
Alessandra, thank you for your talk. I'd like to go to the beginning of your talk, where you distinguish two models of communication, the manipulative model and the informative model. And you said, and I think this is right, that the manipulative model presupposes a competitive scenario between agents or organisms, or because it's a bigger view of how organisms relate to each other. And I asked myself whether the informative model presupposes a cooperative disposition. And if your proposal of narrative communication as persuasion also presupposes a cooperative, a disposition to cooperate. So I think competition and cooperation are a higher level way of maybe categorizing these different proposals, including your proposal. So maybe we should, first of all, maybe ask ourselves how a disposition to cooperate could evolve in our lineage, for instance, and from which point in time. I don't know, what would you could you say about that?
Can I answer? Yeah. Yes, if you want to answer, no problem.
No, Francesco.
Okay. Okay, that's a very good question, because in our model, there are together competition and cooperation. Because at the end of the process with Homo sapiens specifically, and with the verbalization and the grammar of the language, we have the possibility of a phenomena we call it persuasive reciprocity. That is the possibility to turn taking in the conversation and to change the role of persuasive. In this scenario of conversation, cooperation is together with competition, because in the competition of conversation, the interlocutors have cooperation and inside a structure of competition. What we say is that just the reference just to cooperation is not enough to explain conversation. Conversation is together competition and cooperation. And the manipulative model of information at the level of any modes give us the possibility to take advantage of the role of persuasion in a conversation.
Thank you.
There is a question also by Przemysław, I'm so sorry, I just can't do it. Przemysław Zikuzinski, please.
Okay, actually it's Przemek, that's much simpler.
Yeah.
The spelling is a bit confusing. Okay, thank you very much, good to see you. And
Hi, Przemek.
hello. Actually, there is much more than anecdotal evidence that emerging sign languages start with pantomime. And there is new research by Ana Mineiro on Sao Tome Principe, a sign language, when she documents like the first 2 years of a new language emerging. So these are the data that we don't have for other emerging sign languages. But anyway, I was not going to talk about pantomime, but I wanted to ask a question about cooperation, in fact. But somebody was quicker, but I will ask it anyway. In many models of the evolution of communication, human communication, and specifically language, is seen as anomalous, because we use relatively cheap signals that are not counterbalanced, for example, by the production costs, to give mostly honest information to also to non-kin. And you know, and this is, for example, important like in many accounts, like for example, Tomasello going from imperative pointing to declarative pointing. So it assumes kind of what we call platform of cooperation. So cooperation seems to be kind of the foundational element for any type of sign-based cooperation, not just linguistic communication. So well, you say that there is competition and cooperation, but it seems that without kind of this infrastructure of cooperation that is expressed in many our behaviors and in many our cognitive abilities, such as theory of mind, for example, then any type of sign-based cooperation, any type of sign-based communication wouldn't be possible. So how do you factor in the element of as a kind of as a watershed, as an important change? That is, how emphatic are you on cooperation? And if you're not emphatic, then why not? How do you account for the way languages or sign-based communication is the way human use it.
Alessandra?
Yes.
Because
Of course, we recognize that there is an important and leading role of cooperation in human communication. This is not a way to deny these aspects, but maybe starting from the this platform that you refer to, we can think of cooperation in different ways. So cooperation can be framed within a altruistic model of cooperation, but there is also a selfish way of intending cooperation. These two aspects are intertwined maybe in communication. So this is not a way to deny that there is also an altruistic cooperation, but usually models of communication tend to emphasize, to stress the role of altruistic cooperation as the main role, okay? Our proposal is to include, and most of all at the origins of language, also a kind of selfish cooperation eventually. So I don't know, Francesco, if you want to.
Can I add just a brief comment to the issue raised by Shemak? And we are preparing a study on autistic with ISD syndrome. There we have difficulties on counter-argue. It's impossible for children with ISD to counteract, to contrast a different opinion and in conversation. So in this case, where it's impossible, the competition in conversation, communication doesn't go ahead, it's stopped. They are unable to proceed in communication. They respond, it's possible to respond, but we have the feeling that the communication doesn't go ahead. Our opinion is that in this case, the inability to counter-argue by subject with ISD syndrome is a way to consider the role of competition in communication. So cooperation without competition doesn't go ahead. This is our hypothesis. So in conversation, cooperation is a basic characteristic, but without competition, we doesn't have conversation. We have communication, but not conversation. And what is typical for human being, specifically of Homo sapiens, with a verbal and with a grammatical complex language, is conversation. So this is our hypothesis.
Sorry, can I just add a question for you, Przemek? Do you think that counter-arguing is can be seen as a form of cooperation as well? So to reply to your answer with a question.
No, I guess it can be, yes, but I guess I ask, my question was kind of much more basic. So if you have a sign that stands for something, particularly when you have displaced communication, when you could communicate about things that are not present here and now, then to believe in relatively cheap signals, it requires a lot of trust. And for the communications system to be stable, yes? So then when I ask about cooperation, you know, just like in most of the literature on the evolution of communication, I'm asking it with this intent, yes? So it's not so much about altruism or private motives, but it's kind of more from game theoretic perspective. And that's why for many people, this type of cooperation is a game changer, yes? That allowed for the emergence of sign-based communication and later a particular form of sign-based communication and language. You know, so I meant cooperation at this kind of more fundamental game theoretic way.
Okay.
So I guess you agree with me. So.
Thank you very much, everybody. I know, Amadeo, that you also want to make a comment on Vico. I see that in the chat that you say, I would suggest the work of the Italian philosopher Vico, who also championed the idea of pantomime, mimesis, and fantastic universals before the logic universals, argumentative plenty, developed. Perhaps that is something that we can move to the breakout rooms, because now we should move on to the next speaker. Thank you very much, Alessandra, and also Ines Adornetti, who is here in the audience, and Francesco Ferretti. Thank you very much. And then Francesco, he has prepared the introduction to our third speaker today. So Francesco, please.
Yes, sure. It's time for the last of talk of this webinar. Is Robert DeSalle, who works at the American Museum of Natural History, and this is a principal investigator of the Secular Institute for Comparative Genomics. His research interests are in molecular systematics, microbial evolution, and genomics, with a focus on several topics related to evolutionary genomics of numerous life forms, ranging from bacteria and plants to insects and mammals. Today, he will talk about the misuse of genetics and genomics in understanding race.
Rob, you got to
There we go. Sorry about that. Can you hear me now? I'm going to move us out of the realm of cognition and consciousness and language and into the realm of how we view ourselves as a species and how we might see ourselves as having differentiated. Dobzhansky, famous biologist, once said that names are important, and especially names are important in biology and in studies of humans, because they're given to things like races, species, and genera and other categories because names are convenient in writing. And this is an important idea as to how the concept of race has been very important in how we view ourselves. In 1936, in the magazine Nature, from an anonymous writer, the writer said that it is race itself has two main connotations, one being community of descent and the other distinctiveness from other races. And what this means is that race has a connotation of ancestry to it, but also a connotation of taxonomy to it. And taxonomy becomes a very important aspect of of the things I want to say. However, in 1972, Richard Lewontin showed that the concept of race started to dissolve under genetic scrutiny, and this is his famous more variation within than between idea that he came to as he was looking at genetic variation data. What I want to do today is focus on a book that was written 7 years ago by Nick Wade called The Troublesome Inheritance. And you might say, well, why focus on a book that's 7 years old? Well, part of the reason is that other books are coming out, like Charles Murray's Human Diversity book, and papers are appearing over and over, like this paper from John Furst that appeared about 5 years ago. Both of these publications are making a big splash on American right-wing and American nationalist websites, and also on highly visible racist websites. And so the concept of race becomes an important one, and looking at how to think about this in a different way is really important. And the reference in my title to Mr. Murray, You Lose the Bet, is a part of a review that Murray did for Wade's book. Murray said, the orthodoxy's clerisy will take a route ransacking the final 5 chapters for racist material to accuse Mr. Wade of racism, pseudoscience, reliance on tainted sources, incompetence, and evil intent. You can bet on it. But it turns out that it's very easy. These last 5 chapters are chapters that Wade wrote using a racist approach to society, human nature, Jewish adaptations, historical incidences of racism, etc., that Wade thought he could tie to the fact that races exist. But it turns out that it's quite easy to actually go into the book and debunk most of it based on what he says in the first 5 chapters. And this is because he commits several sins. He commits, and I'm going to talk about actually 5 of these really quickly. The first sin that he commits, it's really a terrible one, is subjectivity in defining race or misunderstanding of what a species is. And then the second mistake he makes is a misunderstanding of the nature of science, really, and the nature of hypothesis testing, under which 3 other major sins are committed. And so to go to the subjectivity in defining race or misunderstanding of what a species is, we need to go back to what scientists have thought about what speciation is and what differentiation is. And this is a famous diagram from a German biologist, Willy Hennig, who pointed out that while hierarchy can be inferred for individuals, such hierarchies mean little with respect to the true relationships of the individuals concerned below this event. So this event right here is a geographic or geologic or an adaptive event that separates a once reticulating, once genetically communicating population from 2 separate lineages. And in that sense, those 2 new lineages start to differentiate and start to become separate entities. Below the point, though, organisms are continually cross-talking genetically. They're interbreeding and they're swapping genes and merging lineages so much that any attempt to infer hierarchy for these individuals results in a tangle. And hierarchy in this context means a tree can be drawn. And evolutionary trees have been very important components of modern evolutionary biology, modern understanding of relationships of things to each other, as Ian showed in one of his first slides in his talk. These trees mean something, and the use of these trees in racial science is something that is a major problem. Modern differentiation theory after Hennig in 1966 has gotten more and more complex, but the problem still remains. No matter if you use these more modern statistically based approaches, you still have the problem of what happens above and below this particular point where things start to diverge. And so it becomes important to think about taxonomy and to think about what we mean with the names that we give things. And so species means something really important and really definable to taxonomists and to scientists. Species are diagnosable. They're diagnosably distinct from each other. A subspecies, on the other hand, could be a useful taxonomic term but it really is only a hypothesis of species existence. And it means that when you call something a subspecies, you're calling it such as a hypothesis. You're not really saying anything real about that subspecies or about that entity that you think is there. Populations, on the other hand, are the functional unit of Darwinian evolution, and they are defined by the researcher as that researcher starts to examine aspects of the genetic dynamics that go on in a population. Now, race, we don't know what it is. Race is something that can be a hypothesis. It can be something that might mean something, but in general, I think what Michael A. Patton has said about race is that we should probably relegate the term for use by sociologists and politicians who are enamored of purported differences among humans and who are enamored of having a genetic basis for differences among humans. Systematics, which is the process of figuring out the hierarchy of things, needs to postulate little except that a tree exists and is recoverable by studying attributes of individual organisms. And if that tree exists, then you have hierarchy and then you have differentiation. And this view has led to the suggestion that there's a line of death that exists between that part of the diagram that I showed you earlier above the triangle and that part of the diagram below the triangle. You see hierarchy or you see treeness above it, but you don't see treeness below it. And the line of death approach is the most appropriate, least subjective and stringent, and therefore in Popperian terms is the most severe way to look at how populations are structured. And the second point with respect to race and the major misunderstanding, and it's not just Nick Wade who makes these sins, it's anybody who, it's these other publications that I was mentioning earlier, and it's actually a problem that most people who do racial science have a problem with. And the second one is misunderstanding the nature of hypothesis testing. And just to put it simply, you can have a hypothesis of racial existence, of the existence of races that states there are N races of a type of organism that correspond to the N geographical divisions that we see on the planet today. These are usually taken as Africa, Asia, and Europe. It's a very simple hypothesis and a very simple one to test. And how do you test it? Well, the only way to test it, in my estimation, is with a tree. And the tree that you get is a test of that hypothesis and will reject, will weigh in on the rejection of that hypothesis. Human geneticists also want to cluster their data and also want to structure their data. And these two approaches are approaches that I want to, these three approaches are approaches that I want to take a look at with respect to real data. So for what I'm going to show you, the data are taken from what's called the 1,000 Genomes Project, which are genome sequences of over 2,000 individuals. It's misnamed, completely misnamed. And from the 2,000 individuals, there are about 514 in that data set that have multiple sources of data for an X chromosome, which is semi-clonally inherited, a mitochondrial DNA, a Y chromosome, which is clonally inherited, and chromosome 20, which is biparentally inherited. And when you draw trees for the sequences from these different sources of data, you get things that look like this, where the terminals are colored with respect to geographic origin. And the trees don't have the hierarchical structure that would be a way of affirming that hypothesis. So none of the trees that you get when you do this tell us in any way whatsoever that we have races of humans on this planet. And when you combine everything, it gets even worse. That's the concatenated version of the tree over here. So let's go to clustering. Well, clustering with using a statistical technique called principal components analysis was invented to simplify the appearance of complex data. And believe me, sequence data are incredibly complex. This PCA can be used to reduce the number of variables in a data set by discovering the variables that contribute the most to the structure of the data. And the best way to do this is to determine the variables that explain the most variance in the data. And this is exactly how researchers do this. They characterize the amount of variance on two principal components, then they graph them. And if the individuals from one geographic locality, say this blue locality, cluster in the PCA diagram, they claim that there is clustering, and they claim that we have the existence of races. Structuring is a different approach whereby the genetic data are used to, in a Bayesian context, used to make a prediction about the population origin of an individual. So each column in a structure analysis is an individual, and the bar represents the probability that the individual belongs to one or the other population. So this individual on the left has 100% probability belonging to blue, the one on the right 100% probability of belonging to red, and the one in the middle a mixed probability. But what is clustering really? And Anil K. Jain, the eminent statistician, says that clustering is done in many scientific fields. It is therefore not surprising to see the continued popularity of it. It is important to remember, though, that cluster analysis is an exploratory tool, and the output of just clustering algorithms only suggests more hypotheses. It does not answer anything. So these structure analyses of human genomic data and these PCA analyses of human genomic data, although they look like they mean something, they are actually only suggesting new hypotheses. And I think that's a very, very important point, and one that these researchers who tend to prefer existence of race from genomic data make the mistake of using to test their hypothesis. These are not tools for discovering hierarchy, and they are not tools for testing hypotheses. Only the tree-based approach is a tool for testing a hypothesis. And so what is the problem? Well, I want to suggest that ancestry, not race, is what we as scientific observers should be seeing when we study human variation. Ancestry is what we need to use to accomplish biological meaningful association of human phenotypes with human variation. And the use of ancestry in human variation studies is not that well explored at all. But the attempt to use race itself has been used to do the same thing. And the thing that they try to do is to use the genomic data to find associations of race with genetic predispositions for things. This is an important endeavor, really, but using race is not the way to do it. I think using the patterns of ancestry and the chunks of the genome that show ancestry are a much better way to do this. And Lewontin, coming back to Lewontin, we can say that he said once that the taxonomic division of the human species into races places a completely disproportionate emphasis on a very small fraction of the total human diversity. And this is a really important idea. The overall genomic variation that's there, when you put it all together, it says nothing about differentiation within the human species. But when you take small parts of it out and you look at it, you can find the structure that most people want to see. And unfortunately, even when researchers do recognize the limit of racial thinking when studying human diversity, they continue to use it anyway. And Gower in '72 made it very clear that we do this because the human mind distinguishes between different groups because there are correlated characters within the postulated groups. That is, there are phenotypes, or there are states of the group that make us trick us into thinking that we do have differentiation. And Edwards, the famous statistician, pointed out that Lewontin's conclusion in '72, he called it Lewontin's fallacy. And he said it was unwarranted because of the hidden correlation structure of the data and not simply in the variation of the individual factors, which it flies in the face of Lewontin, but at the same time, I think is very important because Edwards admits that what we are using is the hidden correlation structure of the data. And whether or not that is the way to do differentiation studies is the main question. And I suggest that it's not the way to do it because it's not the way that systematics is done. It's not the way that we try to discover hierarchy when we're looking at organisms on this planet. And the underlying correlation structure of the data at the population level when we use human genomics isn't useful in systematics, and hence it's not useful at all in producing a hierarchical picture of individual Homo sapiens, which is what we wanted, which is what people like Wade and other people who use racial biology want to do. They want to find hierarchy there. Analyses using the correlation structure of the data with things like clustering and multivariate statistical analysis are telling us something different about our history than what systematics would want to say. And the underlying correlation structure, which is telling us about our history, is indeed interesting, but it has nothing to do with taxonomy or with the hierarchical arrangement of our species or of individuals within our species. We'd be better to make better progress to understand the events and processes that led to our current variable and diverse species. If we abandon a tree metaphor and we abandon this race metaphor for understanding the relationships of individuals within Homo sapiens, then we'd be much better off. In reality, no hierarchy or no tree exists, and theoretically it's useless and inscrutable to strive for one. So then what is the connection between ancestry and human variation? Well, we can only conclude that the lines that some humans insist on drawing between their own groups and others are nothing but a mixture of imagination and ideology. And this mixture of imagination and ideology forces the underlying correlation structure that we as humans are very good at pulling out of systems. It forces us to come to conclusions that are racial and racist in the end. And as such, the stratification lines between humans are poor scientific tools for discovery. We have to get away from this idea of using race in human genomic studies and human disease studies. And I just want to thank Ian Tattersall, who has been a great colleague to me and has helped with a lot of the thinking that I do about this kind of a system. So thank you, and I'll just stop sharing, and if there are any questions, I'll take questions.
Thank you very much, Rob.
Thank you very much, Rob. Questions?
Yeah, I hope that wasn't too off target, but I think it might fit in with what we're talking about today. It is a human trait to use underlying correlation structure of all kinds of things to try to understand what we're looking at, and I think that this whole problem of race is one of how our brains work in that context, but it's not real in any biological way, in any genetic or genomic way.
It is, and I think it relates very much to a current state of like language research, language evolution research, or so cultural evolution research. What happens there more and more these days is that people are trying to make like stages of development of human evolution. And also like they are looking very much into ethnicity formation, how symbolization, for example, underlies some kind of ethnic differentiation. And that debate very much also relates to or is a translation of previous racial theories. And in that regard, my question would be like, what advice could you give scholars outside of genetics interested in human evolution in trying to not go there at all? Because
Well, I thought it was really interesting that both of the previous speakers didn't make any sort of a big deal or any deal at all out of human variation, out of the variation that might exist in human populations. And I thought that was a really interesting, and I think that's the way to approach most of these studies. Now, there is one way that you might use racial lines to study language, and I would bet that if you did that, you would never find a genetic association of language or of any kind of cognitive process with a race. But what you would be able to do is characterize the environmental component, and that becomes very, very important. So there's a really amazing study. I don't know if it's amazing, but it was a huge study done by 23andMe and some, I think, American geneticists. And they looked at the correlation of genes in the genome with educational attainment. Okay, so they collected data on how far certain individuals got in their education and then correlated those to genes in the genome. And the number of genes that were correlated to educational attainment were above 1,000. There's so much epistasis and pleiotropy, and these are genetic terms that involve interaction of genes. There's so much of that going on that you're really not going to find the holy grail gene for educational attainment or for intelligence or for language. You're never going to find it. Dick Lewontin once said that the search for consciousness, for the genes for consciousness, was a silly endeavor, and he said that it was tough luck that we were never going to be able to figure it out. So this study that I'm talking about educational attainment, though, when you look at it overall, when you do a genetic study like that, you can also understand the environmental component, which is so much more important and has so much more of an impact that you can now start to think about using these kinds of studies to characterize the environmental component and not the genetic components. Because believe me, every one of these cognitive traits are going to have massive numbers of genes involved, with none of them having major effect. And you might get at things in the environment. The recent COVID pandemic is a good example of that. When COVID first started, researchers tried to do correlation studies with different races of people, and lo and behold, what they found that people of color are much more, at least in the United States, are much more adversely affected by COVID than people of European descent. And so you could say, well, wait, there's a big genetic component there, or a big racial component there. Well, it's not genetic at all. It's all environmental. Almost the entire correlation structure of it is environmental. So I don't want to say stay away from it, because you could get some interesting information from it about the environment, but there have got to be better ways to do it, better ways to do science than to fall into the trap of first just stratifying your data by race. That's just intellectually lazy to do that when you have a genomics data set and some phenotypes, and you stratify by race. That's the first thing you do usually. I mean, almost everybody does it. And it's just lazy, because we should have a better handle on the phenotypes that we're interested in and try to correlate those phenotypes with the genetic variation that we see on the planet.
Yeah. Also, because you mentioned COVID-19, I here in Europe, they were also saying that those people that have a larger amount of Neanderthal DNA integrated into their genome have a higher disease state and also a higher mortality rate than those who don't. But then I think in the public eye, something like that is easily interpreted as, but those people with Neanderthal genes are more primitive than others.
Yeah, there's a difference between correlation and causation. Again, people with Neanderthal genes tend with Neanderthal and Denisovan DNA, chunks of DNA tend to reside in different geographic places. And those different geographic places then are what are being correlated to the impact of COVID. But those different geographic places have environments too, and those environments are almost entirely what's involved in the impact of COVID on different kinds of people on the planet, different people from different geographic areas. Yeah.
Anton Sukoverkov has a question. Anton, where are you? I don't see you. You're...
Hello, can you hear me?
Yes.
Yes.
Good. Rob, I'm interested many years ago about who are Maya Incas, what are their roots, who they are. Are they special people that, I don't know, that don't have nationality, or they have Asiatic roots? And I wrote some articles that compare Asiatic disease and disease that have Maya Incas and all these local people from South America. So what do you think about this theory that this Maya Inca has Asiatic roots, and we can compare disease of Asiatic people and the local people of South America? Yes.
Yeah. A couple of things about that. One is that I think what we're talking about is ancestry, not race. So I think what we need to do, instead of considering these people as being any people as being part of a race, rather look at the genome as a collection of ancestries and try to figure out what ancestries are being correlated with the disease state. And I think that's the most important way to think about this. And the other thing I want to point out is that only groups of people with very recent common ancestors or very recent ancestry connections benefit from these association studies. And so people from Africa who have huge amounts of variation in their genomes, they're almost impossible to find genetic associations with those people as a group, as a large group, with a genetic disorder. And the same with people from Asia, because they are a very old group of people too. So it's an imbalance that I think, Northern Europeans and Europeans and people of European ancestry take advantage of, that doesn't get conferred on other people. And that's because we are such a recently diverged population of humans on the planet. It works, the techniques work. The association techniques tend to work better with more recently diverged genomes.
Okay, I see. Thank you.
But it's a great question, and I just wanted to end by saying that if we get away from thinking about races of people, and I think what you were talking about, Anton, is ancestry, and ancestry is very different from race in my mind, because ancestry is a more detailed diving into the genome to find chunks of the genome that are common amongst people across the planet.
Yes. So race is kind of generalization, yes, but sometimes it helps, sometimes it's misleading. I think we can conclude like this.
Yeah, but again, I go back to what I was saying earlier. I don't think race means anything biologically. So, and we can show that scientifically and biologically that it doesn't mean anything. So why do we continue to use it? Well, I think we continue to use it because it's easy to use.
Yes,
it's the first thing we do. And the easiest thing is probably almost always the laziest thing.
I see.
There's also a question by David Suarez Pascal. David, please.
Yes, and thank you, Natalie, and thank you, Rob. I was thinking about why is it? Why do you think that race is associated with this? Still associated with this hierarchical vision of life, of nature. I was thinking, for instance, it seems that today most of the people don't think about species in this hierarchical way. For example, we don't think, many people don't think now that bacteria or lower animals are really inferior to human species, and these movements about toward the protection of the environment, of animals, seem to be related to that we have left behind this conception of scala natura, or this Christian and Platonic notion that every essence has a place in this ladder of nature. But it seems that race is still related to these hierarchical notions. But I don't know, because I understand what you told us, in the sense that there are, of course, differences between human groups, but they are not important in evolutionary or scientific terms, or that those differences are difficult to support by taxonomic methodology. But my point is related to how we tend to mix value and differences, because if we look close enough to anything, for instance, to rocks, we can find differences in the composition, but we don't tend to put them, not anymore, in a hierarchical way. But that happens with biological categories, perhaps not with species today, but it continues happening with race. What do you think about this? Thank you.
Yeah, no, I agree that we've broken down the scala naturae, and we consider at least people who are interested in biodiversity consider all life on the planet, all the nodes on the tree of life, to have equal evolutionary importance. However, when a racial scientist or even a racist scientist, a racial scientist to me is someone who uses race in their science, and a racist scientist is someone who uses race in their science to really say something terrible. And when they do this, though, they are interested only in the differences between the group they think they belong to other groups. and whether or not there's differentiation between their group and the other groups. If they use a tree, then they're interested in what is more primitive or what is more, what is further down there. And that's what a tree can tell you is the hierarchy of how things are arranged. And the racist approach to that is, first of all, show that there's a difference. And if there's a difference, then my genes are doing something different from your genes. And then I can explain behaviors and intelligence and all kinds of other things because my genes are different. My group's genes are different from your group's genes. Then they get this hierarchical thing and they can say, well, your group's genes are more primitive than my group's genes. And it just gets worse and worse when you start to throw hierarchy in. I don't know if that addresses your concern or your comment, but it certainly doesn't, that hierarchy doesn't exist and that clustering doesn't exist. And it doesn't exist when you think about our species, which is such a young species, genetically, genomically, paleontologically, we're just a very young species and the differentiation just isn't there. But you still have this underlying correlation structure that the human mind keeps falling back on. We do it really well. We find this underlying correlation structure really easily when we look at things. And when we do genetics, we just have a pile of G's, A's, T's, and C's, right? And there's no underlying correlation structure that we see visually, but we start to use statistical methods and numerical methods, visualizing methods to extract that underlying correlation structure when it's really not there because we're not using the right test to get at that correlation structure or to get at what the variation really means.
Perhaps we should drop the three representations and look for another ones.
I think that's kind of what I was trying to say, and that is that we have to be very aware of what the tools we use do for us. And we oftentimes aren't. Just like we have to be very aware of our capacity as humans to extract underlying correlation structure from the things we see. We have to be very careful about that because it's not the right tool to use to say something about human variation. Whereas, the test has to fit the hypothesis, and it's got to be a test in the first place. Again, these things like PCA and clustering methods are not tests. They're methods that help us visualize data and help us come up with hypotheses. They don't test anything.
I have a
just joke, Rob. We can. I think we should start hierarchy with bacteria because they were first. They were pioneer. They should be at the top of hierarchy, and we humans should be at the bottom. That's the solution.
Yes, I tend to agree with you, Anton.
Yeah.
Thank you very much. In fact, let's end it with this joke. Let's go to the breakout rooms. Thank you very much, Rob DeSalle, for your very interesting talk. Thank you very much, Francesco Ferretti, for co-hosting this event with me. We're going to go to the breakout rooms now. So we're going to stop filming. I just want to say that the next webinar is going to be in May. It's going to be organized together with the Department for History and Philosophy of Science and Technology of St. Petersburg University with Elena, who is here today, and also with Lada. I'm not going to try to do the last name, but so, and we have as speakers them, and also Natasha Vitamor, who is going to be talking about transhumanism.